I'm coming to you today from a shop that makes robots, and you're asking me, why are we talking about robots? Well, there's more than one reason. But first, these are my neighbors. This is the building you've seen in the background of lots of videos we've done, 7robotics. Joey Koenig, thanks for having me over. This is the president of what's going on here. Dave Laracy, this is the CEO of what's going on here and of the parent company, Convey, and you're going to that shop too. But in the meantime, when I look around in here and I see manufacturing robots, right? That's what we've got going on here. I position myself in front of the one that's got a pile of OSB next to it because I use OSB. And these guys use these robots for manufacturing and aiding productivity with sort of the engineered wood products that come from the trees that we grow right here in Douglas County. So what we're going to do is walk through this shop. It's more of a laboratory. It's more of a research and development and machine shop. But you're going to get a look at some machines that are changing the way that the materials that come from the trees are handled in manufacturing. So who are your customers? I mean, there's no way to answer that, I know. But in general, who comes to you looking for robots to handle wood?
That's a good question. A lot of our customers are in the wood manufacturing industry, and we segment that up into primary wood, so commodity products like OSB or lumber or plywood. And then a second part of that is secondary wood, so anything you then take a piece of wood and make with it. So think furniture, molding, millwork, and things like pallets and fence panels. Okay. So if you go to one of your big box stores and buy a treated fence panel, 6x8 size privacy fence, we assemble those with robots.
Oh, so I can visualize that melamine and door skins and things like that that are nice and smooth will be fairly easy to get a hold of. But you're saying in those decorative fence panels where it's a rougher wood product, you can get a hold of that too? That's
right, and that's one of our niches that we operate in. So our team here has expertise in vacuum, specifically with rough wood, with treated wood with a lot of moisture in it. And as you can imagine, the robot is geared to do things very precise, very accurate, a million times in a row. And you've worked with wood, I've worked with wood. There's no piece of wood that is the same, not one.
Trees are not the same, boards are not the same.
They're not. So our value to industry is reconciling that perfect movement, motion, predictability with a robot with the imperfection of a piece of wood.
Okay, so the future is here. All right, so I've kind of got a picture. I mean, some of the wood products that I've installed in my life could easily be handled with these things, or could be handled. So why? What is it that's driving the customer to go to your website, pick up the phone and call you? What problems are you solving for them?
So our customers call us for three primary reasons. One is safety, one is to increase throughput, and the third is quality control. For safety, I think that's obvious. There's a lot of jobs in manufacturing where you're moving a heavy and sometimes awkward piece of wood all day, every day.
Repetitive action injuries.
Tough on the back, yep. The second one is throughput. So that ties into ROI, of course, but we never want to be the bottleneck with our robots. So we're in line of some bigger process, and we want to at least match the throughput or be faster. So more product per shift. And the third one is quality control. So we'll look at some robots that are helping do things more accurately and more predictable.
More predictable, right.
than a human operator can.
And this must all tie back to the fact that the labor market is different now than it was in the past. It's hard to find people who have a mindset where they will do a repetitive action over and over safely and I mean, it's hard, right?
It is, and you know, with any kind of capital equipment, there's a question about ROI. So we lay out this much capital, how fast can I pay that machine back? And we have those conversations with all customers, and we have to hit some thresholds there. Now, what's a little different these days is you can have a manufacturer who's been looking to hire 10 people in his plant since COVID, maybe, and they've hired 100, but they're still net short 10 people. So the conversation is more, can we have a system that fills in for one or two of those spots? I still need 8 people, but these are jobs that or functions within a process that you just can't find a person to do them
Okay,
currently.
that makes sense. So ROI, in generic terms, what are the ROI targets that your typical customer has to hit? Has this got to be a 5-year payback, a 10-year payback, a 20-year payback? Where do they become motivated?
Typically, we're in the 3 to 5 year
Really?
payback. And that's how we script it out. Now, what we found is a lot of times the payback is quicker than that. We have a case study where a customer had about a 1.5 year payback,
That's sweet.
which we look at as pretty optimal. But anything less than a year is unreasonable in our opinion.
I mean, how many investments pay 100%? None.
None. Right.
And if anybody tells you that they do, they're lying.
That's right.
Yeah.
That's right.
Okay.
Yep.
And this is not wood products at all. This is conveyance for what again?
It's for the agriculture industry. So
Okay.
we're seeing an expanding field of applications. This company's right here in Oregon.
Okay.
And what they do is they grow mushrooms that eventually get milled down into soil supplement. So they sell this to the wine growing industry, to forestry, and even to home gardening.
Okay, so you said that this conveyance racks these things up in these shapes, and then your robot seals the top up?
The seal is done prior to the robot, but
Okay.
we have to pick it up in a way that doesn't tear that seal
You
off.
pick it up, you put it in these bins, and then so the robot takes these things that are just random and gets them ready to ship.
That's right.
Wow.
Yeah, and we're running this at close to 100 per minute.
So just like a second and a half to do that.
Yes, sir.
Wow. Okay, you would wear out a big crew doing that.
Yes, we would. Yeah, and the idea is that once these go into the grow room and come out, we would then reverse that process to depalletize these.
Oh, it comes out of the. Wow.
Yeah.
And this is not the first one of these. This is in a lineup of several you said you were doing for these people?
We have plans to do several. This is the first,
This is the
but
prototype.
it's a common application. Palletizing with the robot is widespread.
Okay.
What makes this challenging is the nature of how these are sealed.
Yeah.
And the speed.
And so Joy pointed out to me that these have been, I'll say inoculated. That may not be the word, but there's fungi in here.
There is,
The
yeah.
mycelium, white
Yeah, so be
stringy
careful.
stuff. Yeah, don't put that on your cornflakes. But anyway, I mean, who knows? I mean, and you're going to discover more and more ways that you can apply this stuff.
That's
expect.
right. Yeah, and a lot of what we do is talk to our customers and collaborate and brainstorm about where we can use technology that's getting better in different applications.
So this is for wood product processing. How?
So what we've seen earlier is material handling. That's our bread and butter. But we also use robots to do processing, and that could be screwing, nailing, gluing, stapling, painting. This one is actually has a multifunction. So we're assembling an architectural grade product that is high tolerance, and it goes up on ceilings or on walls. This system.
And carpenters like me install.
That's right. Yeah, and so you line these things up over a big ceiling, and they have to be perfect, or else they're going to get out of line over a distance. You'll see it.
Yeah.
So we've got tolerances of about 1/32 dimensionally, and also with the screws, we have to countersink them, but not too much.
So this machine is drilling and screwing and drilling and screwing and drilling and screwing.
It is, yeah. So we drill a pilot hole, we offset the robot over that hole, and then sink a screw in it.
Right now.
Yep, and we're removing shavings as we go along.
Okay.
Yep. And the idea here, Scott, is we've got, as you can see, we've got 2 tables, and an operator interfaces with this machine. That's pretty common. And he's going to load the product. He's going to arrange the boards. We'll lock this down with air cylinders so that nothing moves.
So this is a jig. These are jigs.
These are
that I'm
jigs.
making.
That's
Okay.
right. Yeah.
Okay.
Yeah. So these are machined plates with dowels, and so we'll lay in the wood, and we need these to be tight. We need this to be secure, because when it is, the operator presses go, and the robot moves over this product. The operator stays outside of the cell, and the beauty of this is once the robot's working, he or she can go load that table.
The next set of jigs.
And the idea is continuous manufacturing there.
Okay, so I'm looking at this, and the holes are within a 32nd. That is roughly 30 thousandths. But this table that this is on, these holes are much tighter tolerance than 30 thousandths, right?
Yeah, this table has a higher tolerance, and we utilize shops like Convey just up
Your
the
parent
road.
company.
That's right, and others who have. You really have to have a mill with a table or a bed big enough to hold 10 feet on this
Big.
one.
That's a big machine.
And in the state, there's only a few shops that have something like that.
Okay, so I can see the accuracy here. These are little pneumatic cylinders that clamp and hold the work. And this has been machined to some number of single digits of thousandths or 10 thousandths. It's tight down there.
1/10,000th over a foot for
Per
this
foot.
one. Yep.
Pretty flat, pretty darn flat. But the machine needs that so that the accuracy there, coupled with the accuracy here, gets you exactly the product.
That's right, and we really are belt and suspenders on the flatness because the robot can compensate for some degree of irregularity here. The robot has some tolerance, but we want to make sure that this is as tight as it can be.
Yeah.
To make it easy for the operator.
So this takes to its zenith the construction thing that if you measure small, you miss small.
That's right.
So you measure just as small as you can in every step so that it's a bullseye.
That's right. Yeah.
Cool. All right. So we're going to wrap this up, but what else do we need to see, Joey, while we're here that helps us understand design or process? I mean, the craftsmanship and the machining is something that blows me away. So one of the things that I had to ask Joey about was what's the thought process about making machines that do the work that a person can do? I mean, there's going to be some number of people that won't be working when these machines are installed, right?
That's right. Yeah.
And one of the things that he responded to me with, which is entirely valid, especially from the perspective of someone who's lived in Roseburg for his whole life, pretty much, is that yes, there's a number of jobs that won't exist, but it's hard to find people that are willing to do those jobs now. But there's creation of jobs right here, and in the spin-off application of making these robots, right?
That's right.
Manufacturing jobs.
Yeah, and it's a dynamic situation. So we focus on the jobs that we're creating here, and they're good jobs, both in engineering and sales and manufacturing.
Yeah.
Also in the supporting roles of accounting and admin. So
Sure.
there's job creation here, but we certainly are sensitive and aware that people get placed not just by robotic automation, but by any automation, which is an extension of something that started 150, 200 years
That's
ago.
right, with steam.
That's right.
John Henry and the steam drill, right?
That's right.
I mean, that is automation. And there's no answer to this. There's only whether or not we're going to concern ourselves with it for our neighbors' benefit, whether or not we're going to help our children receive the training they need to be employed and employable.
Sure.
But most of it is teaching our children to work. Because if a person learns to work and enjoy work and the fulfillment that comes from work, you're always going to find work. And I'm conflicted, but I appreciate the fact that painful jobs are less painful with machines, right?
That's right. And one thing we focus on too, Scott, is we have a lot of tours in here with students and adults to show them what we're doing, but we're involved in robotics clubs and different educational efforts. We also are very involved with UCC's mechatronics program, so we advise on curriculum there, and I'm on the board of that program. So when people ask us, what the future is and how do I acquire those skills, we have an answer for them.
Yeah.
And right here in Roseburg.
Right here in Roseburg.
Yeah.
Stay home and go to work at a tech shop.
That's right. You don't have to leave. We've got something for you right here.
You don't always have to leave. That's good. So Joey was telling me that a couple guys from Ukraine?
Ukraine.
Some Ukrainians came in and tore out the old crane and put in the new crane. How fast did they do this?
Scott, they showed up at 9 o'clock in the morning and were out at 7 that night.
With the crane in.
Yeah.
Tore out the old
Yeah,
one.
they took out the old one and put this one up.
2 men.
Two men.
4 scissor lifts and a telehandler?
Yep. Yep.
Good grief. I wish I would have had a camera here then.
And some cutting torches, and there was metal falling on the floor, and it was really impressive. In fact, I went home to get a bite to eat and was going to bring my kids back up to watch them put the final crane in and mount it, and they were done by the time I got back.
So this is the engineering room. Looks like you've got stations here for, wow, 2, 4, 6. You can put a dozen people in here.
That's right, yeah.
Okay.
And we need a dozen.
You need a dozen people. So there's some kind of a process you've got figured out for brainstorming from concept to plans, right?
That's right.
How does this room facilitate that?
Yeah, so it starts like all good ideas on a whiteboard, Scott. So we get a concept from a customer, we get the engineering team together with the sales team, and we put that on a whiteboard.
Like this one down here?
Just like this one. And we've got them in every room because they are that important to us. So with a lot of projects, we can choose between 1 or 2 or 3 paths, and we want to
different directions.
Okay. Yeah, in the engineering process. So we want to get everybody involved in that. So everybody's got different experiences and different disciplines, mechanical, electrical, mechatronics guys. And we want to pick a good plan, so we do that on the whiteboard.
So what the whiteboard does is gets a way for everybody's conversation to be understood by everybody in the conversation.
That's right.
And so you can,
Yeah.
it's just kind of it's a Wild West brainstorming session. Everything's available. I mean, anything can be brought up.
That's right. That's
no dumb
right.
ideas.
No dumb ideas. So there's a brainstorming session, and then obviously, we've all got things in our head that you get it out on paper on the whiteboard. And then we start narrowing that down and picking a path, and once we do that, we'll probably iterate with the customer, sound this, use them as a sounding board.
Because not only do they have a vote, but they have knowledge.
Oh, they have tremendous knowledge.
Yeah.
And that's our posture always: is you make your product. We're not experts in that. We are experts in automating a piece of that.
Yeah.
So let's work together.
Okay, so that must be fun to watch this happen, to get a bunch of smart, educated people. So let me ask you this. Has this changed the way that you brainstorm with people in other aspects of your life to see this sort of thing happen here?
Well,
or is it completely different?
Well, I did put a whiteboard in my garage. Yeah.
Okay.
So me and the kids brainstorm too, and
awesome.
and doodle mostly. But it's fun to see an idea that's sort of nebulous and in different people's heads get out onto one place, and ultimately it manifests in real hardware moving real product. But it starts here at the whiteboard.
So there's some fulfillment in that. Getting back to this craftsmanship thing. This is a type of craft.
It is.
It is mental, shared, teamwork, craftsmanship.
That's right.
That's awesome.
That's right. One cool thing about our shop is not only do the engineers do the design work at these workstations, drafting and making drawings, simulations, but once all that's done and we've got the equipment assembled, we shop test outside. So there's not a lot of engineers up here this morning because they're out testing equipment.
Down on the floor.
So it's in their heads, it's on the screen, and then it's in their hands where they have to ultimately test that out and commission it in the plant. So
that's cool.
They're along with it every step of the way.
That's cool. So what's the most outlandish, unexpected, far-fetched, science fiction worthy machine you guys have made so far? What comes to mind if I say, what's the craziest machine you built?
Well, we have looked into putting a skill saw on a robot, Scott, but we haven't done it yet. A big one, actually, for cutting timbers. But what we have deployed is several systems that nail pallets together. So we've got a nailing head and a vacuum bar, and we've actually tested to see if we can shoot nails, and it's pretty safe. So it looks dangerous, but it's pretty safe.
That's awesome.
Yeah.
Well, we're going to look forward. So last question before we wrap this up. If you had a crystal ball, we may have talked about a crystal ball already, but what would you like to see come out of this shop 10 years down the road? Do you have an answer on that? Have you ever fantasized about what would it be that we could automate right here out of Roseburg, Oregon?
Well, what I see is bigger, what we would call plant scale automation, where we're integrating multiple robots, and we have some systems with 2, but where we actually take a process where we're cutting, gluing, positioning, And so multiple robots working together, that's
Stacking, palletizing,
stacking.
out the door.
That's right. But no matter what we're doing, Scott, what we take a lot of pride in is we've got homegrown talent from right here. We're attracting talent and good, hardworking people from other parts of the country. And we make all this equipment right here in Roseburg, and we ship it around the world. So
There's not a lot of people doing this kind of thing in Roseburg, I can tell you that.
yeah, and again, we're just building on a history of engineering and industry that was already here.
Multi-generational.
That's right.
Not just right here in Roseburg, but right here in this building, in this very building.
Yeah,
Wow.
it's in our DNA.
What a great neighbor you guys are. Thanks,
Wow.
Joey. Thanks for having us over.
Well, thanks for coming to see us, Scott.
I understand better what's happening now.
Yeah,
So let me just tell you this. I walk into these places of business and you can kind of sense there's a feeling, there's a spirit. I don't feel any pressure or tension here. I don't see anybody with scowls on their faces. I don't see anybody exhibiting resentment or frustration in the things they're doing on the floor. I commend you for taking the helm and keeping this a livable place for people to work. I admire that. Thanks for watching Essential Craftsman, and keep up the good work.